All right, this is question 4 of assignment 3, and the question gives us a subset A of the real numbers R, which is bounded above, and it lets A naught be an upper bound for this subset A. It wants us to prove that A naught would be the supremum of A if and only if for every epsilon larger than 0, there exists an element A in set A such that A naught minus epsilon would be smaller than this element A. Okay, so we'll divide the proof up into two parts, if and only if, and we'll start with the if part. If, okay, so if for every epsilon larger than 0, there exists an A in set A such that A naught minus epsilon is always smaller than this element, and we know that an A naught is an upper bound. This implies that A naught minus epsilon, which is smaller than A, would always be smaller than or equal to A naught, right? And for the largest A, which we set equal to M is still smaller than or equal to A naught. And all A in A is smaller than A naught. That implies that by definition, that A naught is the least upper bound of A, and by definition, A naught is the supremum of A. Okay, that's the first part. And then now we move on to the only if part. So in the only if part, we let A naught be the supremum of A, right? And again, that implies that A naught minus epsilon is smaller than A, which is smaller than A naught. We prove this part by contradiction. So suppose that okay, so we prove this part by imagining two scenarios, right? The first scenario would be as epsilon approaches 0, what value A naught minus epsilon would be. And the second scenario where we imagine epsilon to approach infinity and what small value A naught minus epsilon would be, right? So as epsilon approaches 0, suppose right? So if we imagine epsilon approaching zero, then a naught minus epsilon would be an arbitrarily big number in the set A, and if there isn't an element A in the set A that's larger than epsilon, then a naught minus epsilon, that implies that a naught minus epsilon is either larger than or equal to A, which implies that a naught minus epsilon is larger or equal to a naught, which is a contradiction, right? So a naught minus some positive number, no matter how small, cannot be larger than or equal to a naught. Thus, a naught minus epsilon is always larger than zero, smaller than a, sorry, for every epsilon larger than zero. Now, as epsilon approaches infinity, suppose that there exists some x in A such that a naught minus epsilon is smaller than x, and x is smaller than a, right? So suppose we have a value x in a set A that is smaller than A, right? So if you imagine that epsilon goes to infinity, we can imagine that a naught minus epsilon, this value epsilon that's very close to infinity, a naught minus epsilon will be a very small value. And if you can imagine smaller and smaller values of that, if you can imagine that an element x in A that's smaller than A, because epsilon is very close to infinity, this implies that a naught minus epsilon, sorry, this implies that x is smaller than a naught, right? Because if x is smaller than a and a is smaller than or equal to a naught, then x would be smaller than a naught. Then that would imply that there exists some value m in a such that x is smaller than or equal to m, and that implies that m is smaller than a naught as well. And then a naught, that means that a naught is not the supremum of a, right? M would then be the supremum of a. So this can't. So there's a contradiction here. Thus, there is no value of x in a such that x is smaller than a for all a's in a. So then A naught would only equal to be the supremum of A only if for every epsilon larger than 0, there exists a such that minus epsilon smaller than 0. Sorry. In summary, A naught equals to sub A if and only if for every epsilon larger than 0, there exists an element A in the set A such that A naught minus epsilon smaller than